We are going to talk about hydrates and determining the formula of hydrates in this video. What a hydrate is really just ionic compounds with water molecules trapped inside. And only ionic compounds can do that because ionic compounds have a crystal lattice structure. So larger ionic compounds with a crystal lattice structure have spaces in between their atoms or their ions, and so water molecules that are small can go inside and be trapped. The formula of a hydrate looks something like this. So if our example is copper sulfate, if there are water molecule trapped inside it, the formula will have a dot in the middle, and it will have a number and then the formula for water right after. So what this means is that there are 5 H2O molecules trapped in every one formula unit of copper 2 sulfate. So that's what the formula of a hydrate looks like. When you name it, you name the ionic part. So in this case, this would be called copper. Copper is multivalent, so we have to add a Roman numeral to say it's copper 2 plus sulfate. After that, you're going to add the word something hydrate. Okay. The blank there stands for, in the blank there, we put in a prefix that represents how many water molecules there are. So these are the same prefixes used for naming molecular compounds. So we're talking about mono, di, tri, tetra, penta, oops, that's a 5, hexa, and so on. So in this case, because there are 5 molecules, we will name this a pentahydrate. So the formula has an added dot H2O after the formula of your ionic compound. The name has an added hydrate after the name of the ionic compound with a prefix indicating the number of water molecules. So we'll go on to calculate the formula of a hydrate given some experimental data. For example, a 38.11 gram sample of a hydrate has the formula CuCl2.xH2O. After heating the sample, the mass of the anhydrous copper 2 chloride is 30.06 grams. Determine the formula of the hydrate. So they already told us what the hydrate is, except we have to find out how many water is trapped inside one copper 2 chloride formula unit. When they say heating, what heating does is that it boils all the water molecules away. Okay, so this boils all the water molecule out of the hydrated compound. And what you're left with is the compound without the water. So after heating all the water out, the leftover of it is just copper 2 chloride. So when they say anhydrous, this is the compound. The word anhydrous means the compound without water. So that's what this question is saying. So at the end though, we still want the formula of the hydrate. So at the very end of this question, our final answer should look like CuCl2 dot blank H2O. That's what our final answer should look like. Which means we're interested in finding this number, okay? And as a reminder, the formula of a hydrate, or for a formula of a hydrate, we always talk about one formula unit of copper chloride. Okay. So we're really looking for, in one formula unit of copper 2 chloride, how many water molecules are there. So this is now a ratio of copper 2 chloride to water, or a ratio of the moles of copper 2 chloride to mole of water. So again, what we are getting at, just like empirical and molecular formula, at the end is a mole ratio. And the numbers they gave us are mass. So just like before, you're given a mass, you're going to find moles and then the mole ratio. Except this time, instead of finding mole ratios of elements, like mole of carbon to mole of hydrogen to mole of oxygen, you're finding a mole ratio of a compound. So we're finding a mole ratio of CuCl2 to compared to water. So that's the only difference here. Okay? Which means we need moles of this and moles of that, which means we need mass of this to mass of that. So let's start working on the question. CuCl2 and then water. That's what we're comparing. So we'll set that up. CuCl2, we know that they told us the mass after heating is 30.06 grams. So 30.06 grams. To find the moles, we need to divide by the molar mass. So the molar mass of CuCl2 is 134.452 grams per mole. After dividing, this gives us 0.2236 moles. So again, anything to do with finding empirical or molecular formula, anything to do with finding the formula, we need to keep more decimal places just so that when you do the mole ratio, you will get a more precise number. For water, so we need to determine the mass of water. So the mass of water is 38.11 minus 30.06 grams. That is 8.05 grams. We took those two numbers and subtracted because this mass has water inside it, and then 30.06 is the compound without the water. So you subtract the two, the difference is the water that got boiled off. So now we can take 8.05 grams divided by 18 grams per mole. And that gives us 0.4472 moles. This is moles of water, and this is moles of copper 2 chloride. Okay, so with those numbers, we can now set up a mole ratio. So mole ratio of copper 2 chloride to water is 0.2236. Again, that's from our calculations in the previous page, to 0.4472. Again, the trick with having a mole ratio that's not a whole number is to divide it by the lowest decimal, which is, in this case, 0.2236. After dividing, you get 1 to 2. So what this means is for every 1 mole of CuCl2, there are 2 moles of water trapped inside. Okay, or we can say if you take out the word mole, it doesn't really change the proportion. So we can say for every 1 CuCl2, there are 2 water molecules trapped inside. Therefore, the formula of the hydrate is CuCl2 dot 2H2O. Okay, so a review of the entire process. What we did was we found the mass of the anhydrous part, the mass of the water. We then used those divided by their molar mass, their respective molar mass, to find the moles of the anhydrous part, the number of moles of water. We then set up a mole ratio for the two, and the answer in whole numbers of the mole ratio gives us the formula of the hydrate. Lastly, I just want to point out that the number here always has to be 1. Always. Because the definition of a hydrate formula is the number of water molecules trapped inside 1 formula unit. So in your calculation, if you got anything other than 1, that means you must have done some calculations wrong before that. So for a hydrate, the mole ratio of the anhydrous part, the part without the water, always have to give you 1. But we don't write the 1, of course, so we erase that.